Okay, so this video we're looking at something called compound interest, and compound interest is probably a part of maths that is used most in real life. So it's quite an important topic just to understand for in the future, because it's all to do with borrowing money and paying money back, and if you're saving money, the interest you'll get on that money, right? And there's two types of interest that you need to know about. The first is called compound interest, okay, which is the one that is used most commonly, and then there's something also called simple interest, which we'll look at in a different video. But today we're looking at compound interest, okay? So just right down to the fundamentals, which I think is really important to talk about, right? What actually is interest? So firstly, right, there's kind of two ways of looking at this. When you borrow money, okay, interest is the cost of doing so. So let's say, right, and this happens in real life, let's say that your boiler breaks down and you don't have enough money to pay for that boiler to be fixed, right? You might borrow money from someone, okay? But obviously, if you borrow money, you can't just borrow it and then pay them back the same amount, because, the company giving you the money, it's a risk for them, right? So, in order to make up for that risk, you pay that company back some money, and that is called interest, right? So interest is the cost of borrowing money. But also, right, if you save money, so the opposite of borrowing, right? So if you save money in your bank account, so maybe a lot of you guys have got bank accounts now, right? If you save money, the bank will pay you interest on that money. Okay, so let's say you've got, I don't know, right, the more money that you have in your bank account, the more you will get from interest, right? Because let's say the interest rate is at roughly right now, the interest rate is quite high. It's roughly around 5%. So if you've got £1,000 in your bank account, right, you will get 5% maybe of that amount each year. Okay, so you'll make money for just having your money in a bank account. Okay, the bank pays you money for having that money in the bank account. Okay, but obviously if you've got more money, like if you've got £100,000 in your bank account, right, you're getting 5% of 100,000, which is going to be a bigger amount. Okay, so when you save money in your bank account, interest is the rate your bank will pay to borrow your money, because, right, having your money in a bank account, banks use that money to invest in the economy and stuff, right? So, they're paying you the interest for kind of using your money to spend it on other things. If that makes sense, hopefully. Okay, so that's the real fundamentals of what interest actually is. And if you've got high interest rates in an economy, right, that's bad for borrowers and good for savers, right? And let's think about it. If interest rates are really, really high, let's go and say, right, it's crazily high, at 10%, that's an extremely, extremely high interest rate, right? That's really bad for borrowers, because let's say you want to borrow some money to fix that boiler. Well, if the interest rate is 10%, you've got to pay 10% back on the money that you borrow, right? Which is not good, okay? But actually, if you're saving loads of money, if interest rates are really high and you put all your money into your bank account, right? Well, because interest rates are high, you will earn more money on that money you've got in your account. So that's really good, okay? And then quite interesting, right, if you go and study economics at a later point, well, this leads to implications, right? If you've got really high interest rates, people start saving in an economy, right? Well, if everyone's putting their money into bank accounts and not spending any money, then there's no cash being spent in that economy. So it could be quite a bad thing, right? Individually, right, it could be quite good for you because you can save more money, but economically, on a macro scale, on a large scale, right, you want money being spent in that economy, right? Because you want economic growth, and that comes from people spending money in an economy. Anyway, that's a bit off topic. Conversely, right, if you've got low interest rates, that's really good for borrowers. So let's say, again, that your boiler breaks down. If interest rates are really low, it's cheaper to borrow that money, okay, which is obviously good, right? If your boiler breaks down and you've got low interest rates, okay, it's not the end of the world. It's still not great. You're still going to pay back some money on what you borrow, but it's not as bad as if interest rates are high. But similarly, right, if interest rates are really low, okay, that's not very good for savers, because let's say you've got £1,000 in your bank account, and let's say interest rates are at 1%, so really low, you won't get that much money for having your money in that bank account. Okay? And is that true? Yeah, it is roughly true, right? The current interest rate, so I'm recording this in 2024 in May. We're in May time, right? It's around, I think it's 5.25%, but it's around 5%, which is pretty high, right, traditionally. So that's quite a high interest rate. So that means, right, it's going to be good for savers. So if you've got money in your bank account, that's good. You're going to be earning more money on that. But for you guys, which you don't have to worry about too much yet, hopefully, if something goes wrong, you need to pay for a car to be fixed or whatever, right, it's going to cost more to borrow that money. Anyway, right, I'm rambling on. Okay. But this video, right, we're looking at something called compound interest, right? And compound interest is, and definitions often aren't always that clear, but I'll go through it anyway, is the interest on the new amount you have each year, right? What does that really mean in practice? Right, let's say, right, we've got Dave invests £3,000 into a bank account for 3 years, right? And it earns compound interest of 10% per year. Right, calculate the total amount of money that David has in the bank after those 3 years. Okay, well, after 1 year, okay, we've got to find 10% of that 3,000 and then add it on. So after 1 year, right, 10%, because that's our interest we're looking at, of the amount, 3,000, is 300. Okay, so you could do 0.1 times by 3,000 is 300 using our percentage multipliers as before, but hopefully we can see that. Okay, so 10% of 3,000 is 300. Right. So if we're increasing by 300, we've got 3,000 our amount plus 300 is £3,300. So after 1 year, if the interest rate, which is ridiculously high at 10%, you're going to have £3,300 in your bank account. So for literally doing nothing and having your money in a bank account, if you've got a really high interest rate of 10%, after 1 year, you're going to have £3,300 in your account, which is pretty good. Right, after the second year, you then take 10% of the amount you've got from the end of the first year. So you would do 10% of 3,300. Okay, well 10% of 3,300 is equal to 330. And then you go and add on that 330 onto the 3,300 to give you £3,630. So this is true stuff, right? If you had an interest rate of 10% after 2 years, right, you would gain an extra £630 because you started at 3,000 for having your money in a bank account, right? Which is a massive increase. 10% is ridiculously high, but we're just going through the principle here. So compound interest, right, is the interest on the new amount each year. So then again, right, the new amount is 3,630. After the third year, you find 10% of that new amount, which is 363, and you add it on to what you're currently at. So 3,630, add 363, and we get to £3,993. So after 3 years, right, of having your money in this bank account with 10% interest, you've now got almost £4,000. You've almost earned £1,000 for doing nothing with your money. It's just sitting in the bank account. So interest is earning you that money. Okay, so compound interest is interest on the new amount we get after each year. Okay? So after 3 years, Dave's got £3,993 in his account, which we can see there. Let's look at, okay, right, so we can also, right, use a calculator and use a formula to help us quickly find and solve compound interest problems, right? The basic formula, they give you another formula in the formula booklets, but it's not particularly useful, not particularly user-friendly, right? Basically, right, the formula is your initial amount times your multiplier to the power of a time. So going back to the same question as on the previous slide, that's what we've just looked at, the same question. Well, the initial amount is 3,000, right? That's your initial amount. You're timesing that by your multiplier. And on the previous video, right, we looked at percentage multipliers. If you're increasing by 10% each year, you're timesing through by 1.1. That is your percentage multiplier, which we looked at in the previous video. If it doesn't make sense, you can watch that video. So we're timesing through by 1.1. And the power of time is how many years you're in the bank account for. So for 3 years. So the power there is going to be 3. And that is equal to that £3,993 that we saw on the previous slide. To really understand the mechanics behind there, I'll go through that quickly now. Because we can understand that this is just saying, right, after the first year, so we had 3,000 was our starting amount. We increased it by 10%. So we're timesing through by 1.1. That is a 10% increase. Right, this is after your first year, so your first year. Okay, well, after your second year, right, you times this amount here, because that 3,000 times by 1.1 is equal to whatever it's equal to. But then you times that again, this amount by 1.1 again. Okay, so then suddenly you've got your first and you've got your second year. And then we're timesing through all of this, so 3,000 times 1.1 times 1.1 again by 1.1 after 3 years. Okay, so that's after your third year. And that is why, right, we get this formula. We've got 3,000, which is here, 3,000, And then laws of indices, you've got 1.1 times 1.1 times 1.1, timesing by itself 3 times. Laws of indices, same base, add the powers, so times 1.1, and there's 3 of them, to the power of 3, which is exactly what this here is saying. Okay, so we've looked at compound interest, right, on the previous slide, really going through what it really means, but in reality, right, we can just go and use this formula here, which is really quick and effective. Okay, and hopefully that made a bit more sense in understanding what the formula really means. Okay, so let's look at a few examples, right? Example 2 and example 3, slightly different, and then we're going to move on to simple interest on the next video. So you can try this one if you want to, but I'll go through them and that will be good. Okay, so Emily invests £8,000 into a bank account for 4 years. Okay, so you've got your initial amount. So the formula again for compound interest is your initial amount times your multiplier, right? And the compound interest, right, is 3% per year. So timesing it through by your multiplier, and then we've got to the power of time. So calculate the total amount of money that Emily's going to have after 4 years. Well, your initial amount is £8,000, so we've got 8,000, and we're timesing through by the multiplier, the percentage increase. Interest means we're increasing. 3% increase we write as 1.03. That is our percentage multiplier from the previous video. Hopefully that makes sense. Okay, and the power of time, or the time, is 4 years, so to the power of 4. And then you just go and put that into your calculator, and that is it. So 8,000 times 1.03 to the power of 4. So after 4 years with an interest rate of 3%, right, we get, or Emily's going to get in her account, £9,004, right, to the nearest pound. So to the nearest pound. Okay? So, right, we can see, right, the increase in what she's got has gone from 8,000 to £9,004. She's earned £1,000 pretty much, roughly, and £4, right, after 4 years of literally doing nothing but having her money in a bank account. It's earned that much interest. Okay, so after 4 years, right, she's got £9,004 in her account. That is your answer. Okay, but we can see that's an increase of around £1,000, which is a lot for doing nothing with your money. Example 3. So, right, compound interest is not only used just for money, you can use it often in terms of biology when you look at bacterial growth, but also in this case, right, we're looking at, you know, a tree's height increasing compoundly, which is important. So we've got, right, a tree's height increases by 30% a year. Right, the tree is 2 meters tall. After how many years will it take the tree to exceed 12 meters in height? This one is a little bit different. So I've got to find this time, after how many years will the height be bigger than 12 meters? Well, I'm going to use a bit of trial and error here. So using my formula, which is up here again, right, this time my initial, it's not an amount, it's an initial height, right, is 2. The tree is 2 meters tall. My multiplier is I'm increasing by 30% per year, so I'm timesing through by 1.3. That's my percentage multiplier. And I'm trying to find after how many years I get a height bigger than 12. Well, let's just choose a year. Let's go for, I've got no idea, let's go for 4. And if that's too small, let's go and make it bigger. So let's go and do 2 times 1.3 to the power of 4. And right, I only get 5.7122, which clearly, right, is too small. I want height to be above 12. So let's make this a lot bigger. Not crazy bigger, because it will quickly compound quicker and quicker and quicker. Let's go and use 2 times 1.3, maybe to the power of 7. Let's try that one. So 2 times 1.3 to the power of 7, which is equal to... Oh, okay, so that one has gone above 12. So 12 point roughly 5 for so on and so forth, which is above, which is good, because it's bigger, it's exceeding 12, so that's above, which is good. Let's just check, right, and I'm pretty sure that's going to be the answer, so 7 years, but let's check 6 years, okay, because that might be above 12. It won't be, but let's double check it. So 2 times 1.3 to the power of 6, what does that equal to? That is equal to, yeah, there we go, 9 point roughly 653, so on and so forth, which is too small. Right, so definitely, right, we can confirm after 7 years, because in our formula, right, this bit here is time. So after how many years? After 7 years, the tree goes above 12 because that's above 12. So the answer is going to be 7 years using a little bit of trial and error. Okay, so that is compound interest. Hopefully that was useful. And the next video we'll look at something called simple interest, which isn't really used that often, really ever. Well, it is used sometimes, but not as much as compound interest. Okay, thank you.